Over the next several lessons, we'll be looking at how to prove triangles are congruent. So before we do that, we're going to review the definition of triangles, congruent triangles, and triangles are polygons, so it's the same idea as congruent polygons, but specifically triangles. And this stuff is important because we'll end up using triangles throughout the rest of geometry to help us prove different things about things other than triangles, such as quadrilaterals and circles. Even the constructions that we did, we can show why they work using congruent triangles. So the idea of congruence, first of all, is just two geometric figures with exactly the same shape and the same size. And so here you see the red triangle and the green triangle. And so triangle ABC is congruent to triangle DEF. Now please remember the order that this is written is important. A corresponds with D. So as you look at angle A, which looks like this right angle, corresponds with D, and then B corresponds with angle E, and C corresponds with angle F. So order is important, and we'll be using that later on. How much do we need to know? Well, the definition of congruent triangles is all 6 pairs of corresponding parts are congruent. So there's a definition that you can put on your notes. If all 6 pairs of corresponding parts, the 3 pairs of angles, and the 3 pairs of segments are congruent, then the triangles are congruent. A phrase that we use here, the CPCTC, is another way we can say what the definition of congruent triangles are, and we'll see this often, so you need to know this. What this is, corresponding parts of congruent triangles are congruent, and we do use that abbreviation CPCTC. So this goes both ways, and I wish this was a double arrow here, like an arrow pointing in both directions, because if all 6 corresponding parts are congruent, then the arrow goes this way, we know the 2 triangles are congruent. But we could also go the other way, and we could say if we know these 2 triangles are congruent, then all the corresponding parts are congruent. So that arrow could go both ways, and that's the definition of congruent triangles. Do we need to show all 6 parts? And that's the nice thing, and that's what we're going to be looking at today, is we don't really need to show all 6 corresponding parts are congruent. We really, in many cases, can just show 3 corresponding parts are congruent. And so what we're going to do, we're going to look at these few different cases. We see them down here, SSS, SAS, ASA, and AAS, and I'll explain what they mean. And there's going to be one more that we learn in the next chapter of ways to show triangles are congruent. So we get to this first one, side, side, side. So what this is saying, we see these 2 triangles, and we see that the 3 sides of this triangle are congruent to the corresponding 3 sides of this triangle. And since all 3 sides are congruent, side, 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 and so we use the abbreviation SSS. So here's one of our first rules, or our first postulates, that if all 3 sides of one triangle are all congruent to all 3 sides of the other triangle, then those 2 triangles are definitely congruent. So if we can just show the 3 sides of one are congruent to 3 sides of the other, you know the triangles are congruent. We didn't need to show all 3 sides and all 3 angles, just all 3 sides. And that theorem, or that postulate, is called the side, side, side postulate. You'll see it written this way, and this is what's in your, can go on your notes there. The abbreviation is SSS, which stands for side, side, side. Here's what it might look like, another example of what it might look like, or you might have, and it says in words, and if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. And this one is a postulate. And remember, postulates are rules that are true, that we accept as true, they don't need to be proven true. The next one we see here is side, angle, side, and we use the abbreviation SAS. And the order of these letters is important. The A is between the two sides, and so the angle is included between the two sides that we're mentioning. So here we have two sides of one triangle and their included angle are congruent to two corresponding sides and their included angle, and so therefore the two triangles are congruent. So that one's called side angle side. So if we can show that two sides and the included angle of one triangle are congruent to the two sides and included angle of another, then the two triangles are congruent. The way that you can see that written in your notes there, you can write it this way: SAS, which is side angle side. Here's what it might look like. And so two sides and the included angle congruent to two sides and the included angle, and here it's written out. And again, this one is a postulate. And so we can use side, 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 and side angle side. We'll be going over a few examples later so you can apply these different things. The next one we come to is angle, side, angle. And again, the order is important. In this case, the side is between the two angles, or it's the included side. And we mentioned included sides, or learned about included sides earlier in the chapter. So here we have two angles of one and their included side congruent to two angles of another and their congruent side. So the triangles are congruent. Now just a reminder, the reason we're showing these different things is the definition of congruent triangles is all six corresponding parts are congruent. So by definition, we might need to show that all three sides of one and all three angles of that one are congruent to the all six corresponding parts of the other. But these postulates help us because we only need to show three things, but order is important. So the way that we see this one written, this is ASA, or angle, side, angle. Here we have angle, side, angle, congruent to angle, side, angle. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then those two triangles are congruent. And again, that's a postulate. And the last one we'll discuss for today is angle, angle, side. Now here again, order is important. This time we have two angles, but a non-included side. So we have angle A and angle B, and then a non-included side, not the one between the two angles that we saw in the last example, but a non-included side are congruent to two angles and a non-included side. So if you know that information, you know the triangles are congruent. You don't need all six corresponding parts, you just need angle, angle, side. So in your notes, you can put angle, angle, side. Also, you might see this written as side angle, angle. That's okay also, because you have the two angles and the non-included side here. So you can write it as angle, angle, side, or side, angle, angle. And you see it written out here. Well, you see side, side, or sorry, angle, angle, side. It's not the one in between them. It's not this one. If two angles and the non-included side of one triangle are congruent to two angles and a non-included side of the other, the two angles are congruent. And notice it is the word A here because there's actually two non-included sides. If we didn't have this, let's cross this out. We could have had that this side is congruent to this side because this is still two angles and a non-included side congruent to two angles and a non-included side. And this one actually is a theorem. We can prove this one true. Actually, to prove it true, we would use angle, side, angle to prove that one true. Now we've seen these four things here. We had side, 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 angle, side, angle, side, angle, and angle, angle, side, which also we could write as side, angle, angle. And we have all these different combinations, so we might think, well, maybe angle Angle, 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 that's another combo. That might work. Well, angle, angle, angle does not work. Notice here at these two triangles, their angles, their three angles are congruent to these three angles, but they are definitely not congruent. So this is a no-no. You can't use angle, 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 or AAA. Another combination that you might see is SSA, which you might think through this, but it has another way we could write it. We could write it as ASS, which I'm not going to put up there. And let me come back to that. So let's, SSA does not work. Side-side angle is not a way to prove triangles are congruent. So angle, 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 and side-side angle don't work. I'm going to go back a slide so you can fill this out. This is what goes at the bottom. These are combinations that are inconclusive. It might turn out that the two triangles are congruent, but it's not a definite, and we need definite. So angle, angle, angle is not a way. So we're never going to use angle, angle, angle to prove two triangles are congruent. And then the other one, we're not going to use side-side angle, or we could write angle side-side. This is not a way to show triangles are congruent. I kind of messed this up here. This angle should not be highlighted here. We have angle side-side congruent to angle side-side, and we notice that these two triangles are definitely not congruent. So you cannot use side-side angle. So moving on to your next page of the notes, this is just a reminder. Here are the things that work: side, 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 angle, side, angle, side, angle, side, and angle, angle, side. These are ones that don't work. If you come up with this combination when you're looking at triangles, you cannot conclude that they're congruent. And so here's a few examples of the worksheet that we're going to work on. I notice here that I cut some of this off, it looks like, while videoing this, but again, here's what I just wrote. Here's what we're going to do here. We're going to state the correspondence type. Now that the correspondence type are these things right here. And we're even going to state this correspondence. This is still a correspondence, but they don't work. So we're going to state it. We're going to write yes if the triangles are congruent and no if they're not, and then write the correct congruent statement for the triangle. I really want you to do this. This will make it easier for all of us if we're saying things the right way. Order is important. Well, we can write the first one however we want, and then the second one we have to put so it corresponds correctly to the first one. So what we're going to do, this underlined part, please put the first triangle's vertices in alphabetical order. So I'll do that as we go along. So let's look at this one. Let's figure out what the correspondence type is. This has two sides and an angle congruent to two sides and an angle. So the correspondence type here is side, angle, side. So that's the first thing we're going to do. Write yes if the triangles are congruent, no if they're not. Well, side, angle, side is a way to show triangles are congruent. So we're going to write yes, they are congruent. And then we're going to actually write the congruence statement. And this is what I'm saying with please put the first triangle's vertices in alphabetical order. This one, ABC, is alphabetical order, so we're going to put triangle ABC. And the other one we have to put the correct order. So what corresponds to A? Well, that's R, so that comes first. It goes from A to B. Well, that's this double marked segment, so we're going to go from R to N because it's a double mark. And then it obviously has to be an X last. And so that's what we would write for that. So the correspondence type is side, angle, side. That is a way to prove triangles are congruent. So yes, they're congruent, and this is the congruence statement. Let's look at the next one. These are not oriented the same. One's flipped over. But what we have here, we have an angle and its included side congruent to an angle and its congruent included side. So that's angle, side, angle. Again, that is one of the ones that can prove the triangles are congruent. So we put yes because they are congruent. And we want to write the correct congruent statement. So I'm going to take my first one here, triangle, and alphabetical order would be AMZ. and I'm going to say that's congruent to triangle, and I need to look at what corresponds to A. Well, that's R. We'll go from A to M, so A to the one with the one little mark on it. So we want to go from R to X, so RX, and the last letter definitely has to be a C there. So triangle AMZ is congruent to triangle RXC by angle side angle. Jump into this next one. We have two sides and a non-included angle. So this is a side-side angle, congruent to two sides and a non-included angle. So that is not a way to prove triangles are congruent. So this is a no. We can't prove the triangles are congruent. And so since we can't, we definitely are not going to write a congruent statement because we don't have congruent triangles. And so that's an example where you would just say it's no because it ended up being an SSA correspondence. And this one here, we actually have a couple different things because these are isosceles triangles. So we have side, 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 congruent to side, side, side. So that's one of the ones that we can use. So we're going to put yes here. We can write this in a couple different ways. First, we'll take this first one, and alphabetical order is CRX. And we're going to say that is congruent to, and C, the way they're set up, we could say that corresponds with B, but in actuality, that's also corresponds with Y. And we'll see here, let's actually look at CR. So CR corresponds with BY or YB, it doesn't matter which way, because these two sides are the same as these two. But we're going to set it up nice and easily like we did here. So CR is congruent to BYA. I'll also write it, we could have written YBA. And if you look through that closely, you'll realize that that would also work. And so we have another one here. We see that the three angles of one are congruent to three angles of the other. Angle, angle, angle. That is not a way to prove triangles are congruent, so we're going to have to put no there. And obviously, since they're congruent, we won't write a congruent statement. And this last example here, it's a little different. It makes you think through things a little bit. Indicate the additional information needed to enable us to apply the specified congruence postulate. So I have two triangles here, and I want to prove they're congruent. And what this is saying is I want to prove they're congruent for angle side angle, using angle side angle. And so what other information would I need? Well, I have an angle congruent to an angle and a side congruent to a side. So what else would we need for angle side angle? Well, I would need angle B congruent to angle D. So that's the extra information I would need there. And so the extra info is we would need angle B congruent to angle D to have, and I'll mark it here. I'm going to get rid of it pretty quickly, but now we would have angle side angle congruent to angle side angle. The next one, we want side angle side. Well, here we have a side and an angle congruent to a side and an angle. So for side angle side, we would need this. We would need AC is congruent to FE, or we can write those different ways because we switch the order, but AC congruent to FE would give us side angle side. And for the last one, angle, angle side, well, here we have angle side, but we actually need angle, angle side. So we're going to want to indicate or say that angle A is congruent to angle F, and that's the other information we would need in order to prove those triangles are congruent by angle, angle side. So that is proving triangles congruent. We have 4 ways to prove triangles are congruent. We don't need to show all 6 corresponding parts are congruent. We can use one of those 4 ways. For your assignment, I want you to finish this worksheet. There was also another worksheet that I wanted you to do at the beginning of that packet, just reminding you how to solve problems involving angle sums. So we know that the sum of the triangle angles in a triangle is 180, and for any other shape it's always the number of sides, subtract 2, and multiply that by 180 degrees, and that will help you with that other assignment.